What's up guys, Ryan Tech here. Today this is an episode about free body diagrams and we're going to be doing an incline practice problem. So read the problem and try to see if you can figure it out. Assumed you've given a go at it, so let's start off with part A. But first, we have to draw a diagram. So this is our triangle, and then we have a box, and then as you see it's going down, and our angle, our theta, I guess you could call it, is 30 degrees, and this is a right angle triangle. As you can see, it's an incline. So now let's figure out part A. So part A says, what is the acceleration if no friction is present? Well, we're gonna have to use the formula sigma of F is equal to ma, and we're gonna have to derive A out of it. Okay? So let's do that. So let's call this force that brings it down Fg. In fact, what we're saying is that we're going to find out Fg and then get the acceleration using this formula. Fg is equal to mg sine theta. And the reason behind this is because if we have, let's say this is a triangle, but let's kind of enlarge it right here. If that's our triangle, and the box is above it, this is our 30-degree angle. Then as you see, if we wanted to figure out Fg, then it would be opposite, which is sine, over hypotenuse, which is why Fg equaling mg sine theta would make sense. So if that doesn't make sense, then don't worry, we have other videos that are going to explain this. Anyways, so that's why. And as a bit of a review, this is our triangle, that's our theta. Opposite over hypotenuse represents the flow of Fg, because that's the direction of Fg that's going towards there. See? Those are the directions.
Anyways, so hopefully that was a much more clearer explanation.
Mg sine theta is equal to Fg. Now we know that the only forces we have, because there's no friction, is Fg. So sigma of F is in fact equal to Fg. But we also said that sigma of F is equal to ma. So we could say that ma is equal to sigma, is equal to mg sine of theta. And now what we could say is that we could cancel out the m's, and then we get left with a is equal to the sine of theta. Now sine of 30 degrees, as you can tell by the 30, 60, 90 triangle, so this is 30 and this is our right angle, so you can see that opposite over hypotenuse and radical 3, as you see that sine of 30, because it's opposite, or I may actually do it in different color to easily visualize, as you can see it's going to be opposite over hypotenuse. And 1 over 2 is equal to 0.5. So in fact, our answer is going to be, so let me erase this. So as you can see, sine of 30, oh yeah, and there's a g right here. So as you see, sine of 30 degrees is 0.5, and g, which is the gravitational acceleration, is equal to, and you kind of have to memorize this, 9.8. So 9.8 times sine of 30 degrees is simply 9.8 times 1/2, and 1/2 times 9.8 is 4.9. So then our answer, our final answer is going to be A is equal to 4.9 meters per second squared. And as you see, that's our answer for part A.
So, let's just put that in the corner. That's our answer for part A, and that is indeed correct. Okay, so
now let's move on to the next question. Okay, so now for part B. In this one, the only thing that's different, they're asking for the same thing, however, they're applying friction. Okay, so now we have some kinetic friction right here. And I'm going to label that as f of k. Anyway, so how do we do this one? Well, it's basically the same. What we're going to say is that the sum of all the forces is equal to Fg, but this time minus Fk, because Fk is going to be pushing it in the opposite direction. And for this question, of course, we're going to have a positive answer for Fk, because Fk isn't going to go in the same direction as Fg. So now that I got that out of the way, now let's just figure this out. So we already know Fg and all that. We know that it's mg sine theta. So now all we have left to do is figure out f of k. So our kinetic friction is equal to mu, which is our coefficient of kinetic friction. As you see, it says it right here. I underlined it. So it's equal to mu k, or kinetic friction, times our normal force. And our normal force, if this is our box, and let's assume this is our incline, then the normal force is going to be the force bringing it up. So that's our normal force. Now the way we figure out our normal force is by saying that it's mg cosine of our theta, which is 30 degrees. Now, how come? Well, it's the same reason that FG is sine of 30 degrees, and MG sine of 30 degrees. It's because if we draw a triangle, and the box is on top of it, and this is our angle, then as you see, if we say adjacent over hypotenuse, it will label the same trajectory as FN, or our normal force. So it's mg cosine of 30, and we have mg sine of 30 degrees. What we're going to say now is that let's just implement this. So what I'm saying is sigma of f, we're going to use Newton's second law of motion, which is sigma of f is equal to ma. Okay, ma is equal to mg sine of theta. And then we're going to minus it by our kinetic friction, which is mg cosine of 30 degrees. Now we could factor out both sides by m, so we could just say m times a is equal to m times g sine of theta minus g cosine of theta. Okay, so now we could cancel out all the m's here from both sides, and then we're going to be left with a is equal to g sine of theta minus g cos theta. Now, if we calculate this, so we know that this part, the first part, is going to be, we already figured that out, that was 4.9. And then we're going to minus it by g cosine of theta. Okay, so if you put this in your calculator, and make sure your calculator is in degrees mode. So as you see, mine is in degrees mode. What I'm going to do is I'm going to say 9.8 times cosine of 30 degrees.
And cosine 30 degrees is 3 over 2. So I'm going to times that, and I'm going to get an answer of 8.487.
Oh yeah, and sorry, I was supposed to add, unfortunately, I was supposed to add a 0.2 here for our mu. So I'm just going to quickly add that 0.2. 0.2 g cosine of theta. So we say g cosine of theta is 8.487, and then we're going to times that by 0.2. So that's going to be 1.69. And that's going to equal to A. Now, we're going to minus it, and that's going to be our final answer. So, 4.9 minus 1.69 is going to be 3.21. And don't forget our units, meters per second squared. So that's it for part B. Now, for part C, the last question. What is the final speed of the box when it reaches the bottom of the incline after 200 meters? Meaning the distance traveled from, let's say, point A to point B is 200 meters. So distance AB is equal to 200 meters. use the acceleration in part B. Okay, now this one requires a bit of kinematic knowledge. So if you don't know anything about kinematics, I recommend you check this video right on the top right that I made into this sort of recommendation. Okay, so if you check that video out, we're gonna go into the kinematic formulas. Which kinematic formula will work in this case? Now, as you see, the only kinematic formulas that will work is V final squared is equal to V initial squared plus 2AD. You see, we started at rest. It's going to be 0. Our distance is going to be 200. Our acceleration is going to be 3.21. And now we're basically done. All we have to do is calculate it and then take the square root of it. Is 642. And then we're going to have to times it by 2. And that's going to be 1,284. Then we're going to take the square root of that, and we have our answer. So our answer is going to be, V final is going to equal to 35.83 meters per second. That wraps it up for the video. Hopefully you enjoyed it, and as always, have a nice day.